This is Lily, saying hello to the sea at Bjärrehalvön where I live. And Lily is one of my 5 grandchildren. And when I think of my grandchildren, I cannot see anything more important I can do than keep on learning about the planet, the climate, and the role we humans have. And do what I can do as an individual to help my grandchildren actually to a better world. Since I worked with environmental issues from different aspects over the years, it comes very natural to use my experience and be more active in my ambition to contribute. And one way of doing that is actually what I is doing today, to give you all a short presentation of polar research and its relevance for us to understand what's going on with the climate. A confession. Look at the textbook I had when studying chemistry in Lund 1975. I marked and underlined the sentence of carbon and carbon disulfide, but ignored the text on what increasing concentration of carbon dioxide meant for increased temperature. Actually, I cannot remember we at all touched upon the greenhouse effect, even if it has been known for a long time at that time. I feel both naive and ignorant when realizing this. Let me now take you to the polar regions, parts of the world that was my everyday work for many years. The Arctic, with its ocean with a maximum depth of around 5,000 meters, with 5 Arctic countries having a coastline to the ocean. Add 3 countries, including Sweden, to the 5, and you have the 8 countries that constitute the Intergovernmental Forum, the Arctic Council. An unique collaboration construction for a defined geographical area. Much can be said about the effectiveness of the Arctic Council, but the Council has undoubtedly established some important agreements for the common protection of the Arctic. Weather and climate patterns in the Arctic can influence weather and climate around the world, particularly in the northern hemisphere. What happens in the Arctic does not stay in the Arctic. Antarctica, being a continent, is quite different from the Arctic, but plays as important role in the planet's climate and weather system. The continent is covered with an ice sheet, at some places more than 4,000 meters thick. The Antarctic and Greenland ice sheet contains more than 99% of the fresh water on Earth. Nobody owns Antarctica. What is allowed on the continent is regulated in the International Convention, the Antarctic Treaty, and Sweden is a part of the treaty. Research infrastructures such as stations, ships, planes and expeditions are needed for the polar research that needs to do field studies and data collections at site. This is Abisko Research Station at 68 degrees north in Sweden, one of the largest and oldest research stations in the Arctic. The world's most capable polar class research vessel. I quote the journal Science, and we are talking about the Swedish icebreaker Oden. Oden is breaking the ice in the Peterman Fjord at the northwest side of Greenland at a US-Swedish research expedition in 2015. One of the fjords at Greenland, which is an outlet for Greenland ice sheet and hence very important for understanding the dynamic of the enormous ice sheet of Greenland. How fast is it decreasing? Sediment cores are taken to get historical data of ice movements. Germany has an as capable research infrastructure in its ship Polarstern. As we speak right now, Polarstern is parked in the pack ice in the Arctic since late September last year and drifting with the movements of the ice and with a 24/7 science program running. Latest plan that includes many changes due to COVID-19 is to come out from the pack ice early October. This expedition will especially give us important data from the dark period in the Arctic. Research infrastructures are often shared in international collaborations. At left, down behind the rock, you can see Ny-Ålesund, an international research village at 78 degrees north at Svalbard. In the forefront, at the ridge, is the air sampling Zeppelin station, where Sweden has been measuring carbon dioxide since 1988. This is the US Mcmurdo station in Antarctica. Almost 1,400 researchers and technicians man the station during the summer period, and 200 are overwintering. Overwintering in Antarctica is certainly a challenge, dark and cold, and with very little possibility to leave the continent if needed. This is me touching the original mark for the South Pole. At the South Pole there is a research station, the Amundsen Scott station, that US runs. Since 1988, Sweden has 2 stations in Antarctica, the Vasa and Svea station. The establishment of the stations and Swedish research in the late 80s was a prerequisite for Sweden to be able to join the Antarctic Treaty, which Sweden wanted to do. A Russian lab 10 meters down in the snow in Antarctica. At the Russian research station Vostok, there is a drilling project trying to reach a non-frozen subglacial lake under 3,000 meters of ice and snow. At this research station Vostok, the lowest air temperature has been reported, nearly minus 90 degrees Celsius. Drilling, retrieving and analyzing ice cores in Antarctica has given us historical data for different environmental parameters. Measurements of carbon dioxide in bubbles in ice cores show how carbon dioxide has varied around 240 ppm the last 800,000 years. Now we have passed 400 ppm, and the speed of increase has never been seen before. The warming of the planet is not evenly distributed. The redder, the warmer, and the Arctic is very red. The phenomenon is called Arctic amplification. If we succeed in not warming the planet more than 2 degrees, which is a mean value for the whole planet, the Arctic should show an increase more than 2 or 3 times the mean value for the planet. The so-called albedo effect is probably the major explanation behind the Arctic amplification. When the white snow and ice surface melts, the surface becomes darker and hence able to absorb more heat from the sun's radiation. Photography has become a very usable method to track changes in the environment. These 2 photos are taken at the same day of the year and from the same spot, but 104 years apart, and changes are very visible. The lake is the Tarfalasjön. In Tarfala, Stockholm University has a research station. Satellites are important research tools for the polar regions. Satellites feed us with, for example, data on Arctic sea ice extent. As you can see on this graph, this year seems to be yet another year with record low extent of the Arctic sea ice. Looking at the decreasing volume of ice instead of surface, it looks even worse for the Arctic. 70% loss of volume between 1979 and 2018, and the oldest, thickest ice, the so-called multi-year ice, is decreasing much faster than the first year ice. We could probably experience an ice-free Arctic in the summertime in 30 years. In Antarctica there is another pattern. There is not the same steady decrease in sea ice as in the Arctic, and warming is more pronounced on West Antarctica. One hypothesis that is presently investigated is that warmer seawater can melt the ice from beneath and lead to abrupt changes of the ice. Sweden and University of Göteborg has started to take measurements under the ice with the help of an unmanned small submarine. Ocean acidification is a result of increasing concentration of CO2 in the atmosphere, which leads to increased uptake in the oceans of CO2. Arctic Ocean tends to take up more CO2 being colder than other oceans, and it has a different seawater chemistry. A lowered pH in the sea is detrimental to many organisms, for example organisms that are dependent on calcium carbonate to form and keep their shells. The climate changes are very real for people living in the Arctic. Reindeer herders have a challenge securing food and grazing for their reindeers. Warmer winter days means that the ground melts and freezes, which gives an icy layer that the reindeers cannot easily come through for grazing. This iconic photo from Greenland, I believe, talks for itself. Permafrost in the Arctic is increasingly thawing. This is not only taking away the ground for housing, but the thawing releases carbon that accelerates the formation of greenhouse gases. Increasing temperature changes the pattern of distribution and migration of species. For the first time ever, mackerel can be found outside Svalbard. New pathogenic organisms are as well showing up in more northerly regions. When sea ice melts, it does not affect the sea level, it is already in the seawater. But when ice and snow on land melts and find its way to the oceans, then the sea level rises. This is a part of the ice sheet on Greenland that is slowly moving out to sea, which is a natural process, but the warming accelerates that process. This is a graph from SMHI in Sweden. Mean value of data from 14 different sea level stations along the Swedish coast, compensated for the land uplift. IPCC reports projected relative sea level change up to 1 meter to 2100. When there is less ice in the Arctic, it opens for shortening time for global ship traffic. It will be possible to more frequently use the northeast and northwest passages in the north. Russia is very keen in developing the northeast passage for commercial traffic because it would mean a substantial business opportunity for Russia. I joined a Swedish-Norwegian expedition with Oden to the Arctic a couple years ago. Part of the Norwegian research program had a clear applied angle, and that was to build a knowledge base on ice properties and ice movements that could be utilized by ships navigating in the Arctic. Oden moored at an ice floe, and the researchers went out on the ice for collecting data on physical properties on the ice. When the captain gave them okay to go on the ice, they were almost like kalvar på grönbete, rushing out and energetically rigging their equipment. But this guy did not pay any attention to science, with his back to the ship and with a rifle looking for any signs of polar bears. If he blew the whistle, the researchers were as fast running on board as they were when they left the ship. All safe on board when this female with her cub came along. A part of the program was to learn more about how iceberg moves. With a sky lift, Oden put this Norwegian professor on an iceberg, and then he quickly planted 2 different dog collars on the snow. Yes, you heard right, dog collars. The collars had the cheapest GPS transmitters, I was told. Later on the bridge, we could follow the iceberg's movements and rotations for several weeks. Our individual responsibility and possibility to contribute to less climate change should not be underestimated. Our daily choices and decisions matter. Flying is a good and concrete example. Authors of an article in Science 2016 calculated the effect from CO2 emissions from flying on sea ice extent and decrease in the Arctic. Imagine a family of 4 flying to Thailand from Sweden and back. Their part of the CO2 emissions from that flight is around 35 tons of CO2. And that leads to that around 100 square meters of sea ice in the Arctic disappears and will not come back next winter. I believe it's necessary and hopefully fruitful to address the present pandemic along with the discussion of our climate crisis. Of many reasons. First of all, I believe there are some underlying similar causes behind the two crises. The way we treat our planet. For instance, deforestation, which adds to climate change, is said to be connected to 30% of recent years' zoonosis. And then, the way we easily can move across the planet, often by flying. Another reason to have the two crises on the table at the same time is to see and learn that societies and individuals do have the capacity to act forcefully and change when there is a crisis. Something we need as much when we deal with the climate crisis as well as the pandemic. I also believe it is of utmost importance when it's time to restart our economies that we do it with the green agenda in mind and do not look for yesterday's normalities, which were not always sustainable.